Hello students. Today we are going to learn Science and Technology 1 and our today's topic is we are going to learn second chapter students. In this chapter our today's topic is periodic classification of elements students. In periodic classification of elements we'll learn elements and their classification, Dobereiner's triad, Newland's law of octave, Mendeleev's periodic table, and modern periodic table. These all topics we are going to cover in this chapter of periodic classification of elements students. When we'll start with this chapter students, in the starting only, you will see there are few questions are given, and these questions are as it is students. What are the types of matter? What are the types of elements? What are the smallest particles of matter called? What is the difference between the molecules of elements and compounds? These are the questions given over here. First I'll explain you answer for these all questions and then we'll move ahead in this chapter students. See students, these all questions are based on our 9th standard syllabus. We have already learned this all in our 9th standard. So this is just a revision and then we'll move ahead in this chapter students. So let us start with first question. What are the types of matter? When we are talking about matter, matter are of two types. One is mixture and other is pure substance. One is mixture and other is pure substance. It is based on does it have constant properties and composition. If the compositions are constant, we'll call it pure substance, and if compositions are not constant we'll call it mixture. For example, when we'll talk about water H2O, here the number of hydrogen and number of oxygen atoms are in fixed proportion, is fixed, it is constant, and that is the reason why we'll call it pure substance. When we are talking about mixture, I'll take an example of fruit salad. When we'll talk about fruit salad, in that fruit salad we can have one or other component, that is one or other fruit more and the few less. We can have different compositions. So this is called mixture students. This is called mixture. Here when we'll talk about mixture, mixture is again further divided into two parts students. Heterogeneous and homogeneous. Heterogeneous mixture and homogeneous mixture. How will we learn? How will we come to know whether the given mixture is heterogeneous or homogeneous? I'll give one example students. I'll give one example. Suppose I am having a glass. In that glass I'll take water and I'll pour some oil in that glass. When I'll pour oil, you will find that oil will float on the surface of the water. Above the water, the oil will float, and you will able to see if the glass is of glass, then you will able to, if the glass is transparent, you will able to see water layer and the oil layer separate, and this is called as heterogeneous here it is a heterogeneous mixture because mixture is not same everywhere. But suppose I am taking a glass, in that glass I am taking water and I'll pour some salt in that and I'll stir it. When you will stir it, you will find that the salt will get dissolved in that, and in that when you will see whether it is transparent glass, you will not able to distinguish where is salt, where is water. You will find the mixture is homogeneous. Homo means same everywhere. But in the first case, when we were having oil and water, in oil and water, when you will see from a transparent glass, you will find that the oil is floating over the water, and both are not homogeneous, not same. The mixture is not same everywhere. Above it is different and below it is different. That means it is different, heterogeneous medium. So this is about mixture, students. When we'll talk about pure substances mean composition is same. Same amount of elements are there in the composition. Now again, pure substances are divided into two parts, students: elements and compounds. What is element and what is compound? Here when we talk about elements, students will see here, when we'll talk about, see, one more same flow chart is there. Matter, we have seen that matter is divided into pure substance and mixture, and we can separate them by physical separation, students. We can separate them by physical separation, then we'll call it mixture. And we can't, that means it is pure substance. Pure substances we can't separate them. Here when we'll talk about mixture, we are having two, homogeneous and heterogeneous. We have seen salt plus water is a example of homogeneous mixture, students. Salt plus water is an example homogeneous. But when we are talking about pizza, when we are talking about solid waste dump, I gave the example of water and oil. This is the example of heterogeneous medium, students. But when we are talking about pure substances, we are again having two examples: elements and compounds. When we are talking about elements, oxygen, hydrogen, iron, these are the example of elements. And when we are talking about compounds, water, table salt, ammonia, these are the examples of compound, students. To understand elements and compounds in more detail, we can have one example. See here, students, when you will see this, here we are having same in this, when you will see element hydrogen element, we are having both the atoms of hydrogen only. When we are having oxygen element, we are having both the atoms of oxygen only. When we are having chlorine, both the atoms are of chlorine only. So here in this, all the atoms are same. If the all the atoms are same, we'll call it homogeneous. We'll call it sorry, students, just a minute. We'll call it element. If the atoms are same, we'll call it element, students. If the number of atoms, all the atoms are not same, for example water, when we are talking about water, water is having molecular formula H2O. Here hydrogen atom is there, oxygen atom is there, both atoms are there, two type of atoms are there. If two or more than two atoms are present in the given substance, it is called as compound, it is called as compound. One more example is there here, and table salt is called as NaCl. Table salt is called as NaCl, students. So NaCl, when we are talking about NaCl, here sodium and chlorine, two atoms are there, students, two atoms are there, so we'll call it again compound, students. But when we'll talk about oxygen is two, both the atoms are of oxygen. Hydrogen, H2, both the atoms are of hydrogen. Iron, Fe. So here when we are talking about oxygen, hydrogen and iron, these are called as elements, students. So we got the answer for first question. What are the types of matter? We are having two types of matter: mixture and pure substances, which are further divided into heterogeneous, homogeneous, and elements and compound, students. So this is the answer for our first question. Let's move to the second question. When we will see the second question, we are having the question, what are the types of elements? So here, types of elements, when we are talking about types of elements, we are having basically three types of elements: metals, non-metals, and metalloids. Metals, non-metals, and metalloids. Metals, how will we come to know the given element is a metal? So there are some properties the metals have. They have luster, that means they are malleable. That means when we'll hammer on them, they can be converted into small thin sheets, students. Thin sheets, sorry, sheets. Now here, ductile, when we are talking about ductile, they can be converted into thin wire. We can convert them into thin wire, students. Here they are strong, they are strong, that means they resist bending, we can't bend them easily. High melting point, they are having high melting point, so they melt at high temperature. They do not melt at low temperature, students. They are having high boiling point. They cannot we if we have to make them to boil, they are having high boiling point. The good conductors, they are the good conductors of heat and electricity, and they are magnetic. Some of the metals are magnetic also, students. That means they are getting attracted towards the magnet, students. So here these are the properties. When a few exceptional cases are there, but we are talking about most of the properties, 90% cases. Otherwise we will say there are few examples who are not having same properties. So exceptional cases we are not talking here. We'll talk about the major properties of metal. When we'll talk about non-metal, students, do not have luster. They do not have luster. Here they do not have luster. They are brittle. Brittle means when you will hammer, they will not be converted into thin sheet. They will be broken down. They will be broken down. Not malleable, that means we can't convert them into thin sheets, students. Not ductile, that means we can't have the small thin wire with the help of non-metal, students. They are having low melting and boiling point. They melt and boil, we can boil them at low temperature as compared to metal, students. They are not good conductors, that means they cannot be used in electrical or heating devices, as they are bad conductor of heat. In the same way, metalloids, when we are talking about metalloids are in between, the case of in between the metal and non-metal. That means they have tendency of both metals and non-metals. Make good semiconductors. We can make good semiconductors with the help of metalloids. Students, it is like in different cases they behave differently. Sometimes they behave like a metal, sometimes they behave like a non-metal. So here these are the case, this is the case of both in between the metal and non-metal. Here they are having tendency of both metals and non-metals. We can make good conductor, semiconductor from the metalloid, students. So this is about second question. Let's move to the third question. Our third question: what are the smallest particles of matter called? When we are talking about matter, smallest particle of metal is called as an atom. Atom is the smallest particle of matter. So atom, the smallest particle that can be called an element, students. That can be called an element. All matter is made up of atoms, students. All matter is made up of atoms. Now when we'll talk about atoms, they are having proton, neutron and electron. Atoms are made up of proton, neutron and electron, students. So this is about the smallest particle of matter. Smallest particle of matter is atom. They can be called as element. Here atom is having three subparticles, or we can say the atom is made up of protons, neutrons and electrons, students. So this is the questions answer. Now last question which we are having in our textbook is: what is the difference between the molecules of elements and compounds? We have already discussed this. When you will see elements are having same atoms. When we are talking about hydrogen element, we are having same atoms, hydrogen. When we talk about oxygen element, we are having same oxygen atoms. Both the atoms are same. Here when we are talking about molecule of chlorine, again same atoms are there. But when we are talking about molecules, students, compound, molecule of compound, we have already discussed the compound of elements. Now we are going to discuss about the elements of compounds. In compounds, here we are having example of water. Water is a compound of H2O, compound of hydrogen and oxygen. That means they are heteroatomic. They are heteroatomic. In first one they were homoatomic. Homo means same. They are heteroatomic. That means they are having two or more than two atoms in a compound, students. In a compound, when we'll see the compound of hydrochloric acid, molecule of hydrochloric acid, HCl, we are having two hydrogen and chlorine atoms. So if two or more than two atoms are there, two or more than two types of atom, two or more than two types of atom, students, are there, we'll call it compound, students. If the same atoms are there, same type of atoms are there in molecule, we'll call it element, students. So you will remember, if the types of atoms are same, it is called as element, it is called as element. If the types of atoms are different, it is called as compound, students. So this is about the elements and compounds. And next we are going to learn is the classification of elements. We are going to start with the chapter now, students. I have answered for all the questions which were given in the starting. Now we are going to continue with the classification of elements. When we are talking about classification of elements, students, till now, till today, we know 118 elements in scientific world, students. However, around year 1800, only 30 elements were known. In the year 1800, only about 300 elements were known, students. In the initial classification, elements were classified into group of metals and non-metals, and later on another class element called metalloid was noticed. So initially when classification started, they divided the elements in three parts: metals, non-metals, and metalloids. So if 30 elements are there, we can say they were having 10, 10, 10, or 10, 5, 20, like this. So easily they could remember the elements. But slowly the number of elements started to increase. The number of elements started to increase. The scientists, they started to discover new elements. So it was difficult to study the elements in the group of metals, non-metals, and metalloid. So as the knowledge about elements and their properties went on increasing, different scientists started trying out different methods of classification, students. So they started to search, they started to develop, they started to work on the different types of classification. Now let's see, it was first attempt of classification was done by, the name is Dobereiner. The name of the scientist is Dobereiner. He was the first who did the attempt, who tried to classify the elements. In 1817, the scientist Dobereiner, he is from German, he is a German scientist. He suggested that the properties of element are related to their atomic masses. He said that the property of elements are related to atomic masses. He made group of three elements, each having similar chemical properties, and called them triads. He named them as a triads. He arranged three elements in triad in an increasing. He took the set of three elements. He took the set of three elements, and he started to arrange the atoms. He arranged the three elements in a triad in an increasing order of atomic masses, and showed that the atomic masses of middle element was approximately equal to the mean of the atomic masses of the other two elements. However, all the elements however all the elements could not be classified into the Dobereiner triads. He could not classify all the elements, but let's see how was the Dobereiner's triad. Here in our textbook, it is given example of a few examples are given of triad, Dobereiner triad. Here first Dobereiner triad given over here is lithium, sodium, and potassium. When we'll see the atomic masses of lithium, sodium, and potassium, lithium is having atomic mass of 6.9, sodium is having atomic mass of 23, and potassium is having atomic mass of 39.1. Now according to Dobereiner, the atomic mass of the middle one, that is sodium, must be equal to the average of remaining two, first and last. So let us check average. When we'll take the average of 6.9 and 39.1, 6.9 plus 39.1 upon 2, it will become 39 plus 6, 45, 46 upon 2 will get 23. So it is exactly same as the middle one, sodium. When we'll talk about second example, Ca, Sr and Ba. Ca, calcium, is having atomic mass of 40.1. Then we'll talk about Ba, barium. It is having atomic mass of 137.3. And the middle one, Sr, strontium, it is having atomic mass of 87.9. Let us check whether the 87.6 strontium is average of first and last or not. What we'll do, students, we'll take the average of first and last. We'll take the average of first and last. What we'll do, 40.1 plus 137.3 will add and will divide by 2. What we'll get here is 88.7. It is near about same as strontium Sr. It is approximately same as 87.6. So here this is called Dobereiner trade. This is called Dobereiner trade. When we'll talk about last example, here in last example we are having chlorine, bromine and iodine. Chlorine, bromine and iodine. First chlorine is having atomic mass of 30.5. Last iodine is having atomic mass of 126.9, and bromine is having atomic mass of 79.9. Let us check this is the average of first and last or not. What we'll do, we'll add first and last, that is 35.5, and last 126.9, and we'll divide by 2. What we'll get is 81.2 here. We'll get is 81.2 here. This is again approximately same as 79.9. We are taking approximate value, we are getting approximately same answer. So here, as the approximate value is same, this is again called as Dobereiner triad. So in this way he arranged the elements in the increasing order of their atomic masses, and he made the set of 3 elements. He made the set of 3 elements, and he named those sets as a triads. He named those sets as a triad. All the known elements could not be classified into Dobereiner triad. He could not classify all the elements in Dobereiner triad, and it was like his theory was rejected by the scientists of that time. They rejected the theory because Dobereiner tried his idea. He could not arrange all elements. He could not arrange all the elements discovered till that time. Then later on, students, after the Dobereiner, see here I am having a few examples for you. Identify Dobereiner's triad from the following group of the elements. We have to check whether this is the Dobereiner triad or not. What we'll do, students, we'll go ahead. Before we'll go ahead, let us solve these examples. We will check whether the given triad is a Dobereiner triad or not. Here, what we'll do, here we'll take first and last. When we'll take first and last, here 24.3 plus 87.6 upon 2. When we'll add this 6 plus 3 9. Here point is as it is. 4 and 7 11. 1 left. 7 and 2 11 12. 121.9 upon 2. 121.9 upon 2. I'll repeat here. When we'll add 6 plus 3 we'll get 9. 6 plus 3 will get 9. 8 plus 4 11. Here 11 is written. 1 is left. 8 plus 2 11 and 1 12. So here it is 12 written. Here 12 is written. Let us divide and upon 2 as it is here. When we'll divide, 2 ones are 2. Here 2 6 are 12. 1 is there, not divisible, we'll put 0. Here we are having 9. So 19. 2 8s are 16. 2 9s are 18. 2 9s are 18. So here we are getting something 60.9 here. We are getting something 60.9. It is not equal to 40.1. It is not equal to 40.1. So this is not a Dobereiner triad. This is not a Dobereiner triad here, students. Let's see the second example. When we'll see the second example here, first atom is 32.1 plus 127.6. Let us divide by 2. When we'll divide by 2, 1 plus 6 will get 7. We'll get 7. 7 plus 2 will get 9. So I'll write 9. This point is as it is, students. 2 plus 3 5 and 1 as it is here. So we'll divide by 2. We'll check what happens. 2 ones are 2, 2 sevens are 14, 2 sevens are 14. 1 left, students, it will become 19. 1 left, 1 left, it becomes 19. 2 nines are 18, 2 nines are 18. So again 1 left, we'll put point. 2 8s are 16. So here we are getting approximate value of 79.8, students, 79.8. So here 79.8, it is approximately equal to 79. It is approximately equal to 79. So we can say that this is a Dobereiner triad. This is a Dobereiner triad. So in this way we can check whether the given sequence, given set of atoms are Dobereiner triad or not here, students. Later these notes here. We'll stop today's lecture here only, and we'll continue with the lecture in the next video. Until for tomorrow, for today, I'm saying thank you to you all. Will